Hey everyone, welcome to your first set of notes for Honors Algebra 2. You're going to find that these notes are a lot shorter than the ones we do in class. I don't do nearly as many examples and I go a lot faster. Feel free to stop the video, pause it, rewind it, do whatever you need to do, but I go pretty quickly. If you have any questions, come see me. I'm here during study hall. I'm also here before and after school. So let's get into this. Direct variation. It says fill in the table using the given ordered pairs. Well, that's -4, -8. -2, -4, 1, 2, 3, 6, 5, 10. And then it says to fill out this column, y divided by x. Well, what's -8 divided by -4? It's 2. -4 divided by -2, 2. 1 divided by 2, 2, 2, 2. What do you notice about y divided by x in the table? It's always 2. This value is known as the constant of variation. I just call it k. Whenever you have a direct variation, y over x will always be the same for ordered pairs. That's one of the ways we prove something's a direct variation. We check all the k values and see if they're all the same. So let's graph this. So I've got -4, -8, -4, -8, -2, -4, 1, 2, 3, 6, and 5, 10. 3, 6, 5, 10. And if I can draw this accurately, there you go. There's a line. But what do you notice about this line? What's the slope? Well, let's pick any 2 points and we'll figure out the rise over run. Let's go between these two. Between these two, I went up 6 and I went over 3. So it's 6 over 3. The slope is 2. Hey, that's the same as the k value we just had. What's the y-intercept of this line? Well, it goes through the point y equals 0. Whenever you have a direct variation, the slope will always be the same as the k value that you get from y over x. And the graph will always go through what point? The origin, 0, 0. Since the slope is the constant of variation and the graph goes through the origin, what linear equation may be used for all direct variation problems? Y equals kx. It's like mx plus b, except m is k and b is 0. When two quantities vary directly, solving for unknown values can be done with a ratio or using y equals kx. I much prefer this one. Using the constant of variation we found on the front of the sheet, that was 2. Find x if y equals 5. So y equals 2x. That's my equation. It says find x if y equals 5. So divide both sides by 2. X equals 5 halves. Just leave it as a fraction. You guys will get used to that. Become friends with fractions this year. Using the constant of variation found on the front of the sheet, so y equals 2x. Find y if x is -3. Well, this is a really easy problem. Y equals -6. Okay. You can do the same thing with k if you want to. You can say that 2 equals y over x. So find x if y is 5. So 2 equals 5 over x. That means that 2x equals 5 and x equals 5 halves. It's the same answer we got because it's the same question, just done differently. I don't usually do the problem this way, but you can. K equals y over x, but I guess k is 2. 2 equals y over -3. Multiply the -3 over it, and you get y equals -6. Again, that's another way to do the problem, but we won't do that in class. We'll use the other method. So, let's go through this. The graph must go through 0, 0. The slope is the same thing as the k value, y over x. The constant of variation is found using what ratio? We just said that is y over x. And what equation can be used for all direct variation problems? Y equals kx. Okay, let's try some examples real quick. Suppose y varies directly to x. So that means y equals kx. When x is 4 and y is 10, so let's stop right there. What piece of information can I now find? I can find k. K equals 10 over 4, which will simplify down to 5 over 2. Now let's rewrite the problem. Y equals 5 over 2x. Find y when x is 7. How do you multiply fractions? You multiply straight across. That's 7 over 1. 5 times 7 is 35. Over 2 times 1 is 2. And just leave it as that fraction. So I wrote y equals kx. I used what I knew to find k. And then I plugged it back in to find what I didn't know. This next example is the same type of problem. It's just worded differently. And people have trouble with this. Suppose y varies directly as x. So y equals kx. Find x when y is 5. That's really the question. This is what we know. If x is 3 when y is 7. So then I know k is 7/3. So now I've got y equals 7/3 x. Find x when y is 5. 5 equals 7/3 x. Well, how do I get rid of the 7/3? What can I multiply 7/3 by that will cancel out 7/3? How about 3/7? But if I do it on the right side, I've got to do it on the left side. These will cancel, and I've got x equals 15/7. And that's it for direct variation. Remember, y equals kx, plug in what you know, find k, and then solve for what you don't. Thanks.